Hello students, hope you all are doing well. Here in this video, we are going to take a look at the topic what solubility of ionic compounds. Then you would quite wonder whether we have such a topic in your syllabus, in our syllabus. Actually, what you truly are having is water solubility of S-block compounds or S-block salts. But learning just the water solubilities of those S-block compounds as water soluble, insoluble or such. Then later on under D block again you would find some compounds being water insoluble and some therefore are precipitates. Let's not waste our time studying or learning same thing at two places differently or separately. So let's combine them together as to talk about the all compounds water solubility. Though it is all the compounds, it's only ionic substances that is in our concern, means that we are going to talk about. Okay, students, it's then therefore the topic here is about the water solubility of these ionic substances. Ionic substances. What do we have in ionic substances? What are they? What do we have in ionic substances? What else? It's ions. It's cations you have, anions you have. So those two ions you have within an ionic substance. Then students, it's based on the cations type as well as anion types. We are going to find some patterns regarding their water solubility of those ionic substances. So you would then find how easy the learning of chemistry is and how enjoyable the learning of chemistry is. Seeing these patterns. Okay, we are going to find out some patterns within this lesson. Students, when you talk about the water solubility of those ionic substances, you could categorize substances into three types. Water soluble, let's call it very soluble, and insoluble and sparingly soluble. You could categorize them into soluble, insoluble and sparingly soluble based on their water solubility. Then students, seeing the cations and anions involved, you could find out some patterns. Sometimes having such cations, it always would follow this behavior. These kind of properties would exhibit. Then similarly, when you have these anions, you could expect some certain properties based on their water solubility. If we are going to check for those patterns and we are going to check for whether there is such, and we are going to learn those and find out how easy those prediction of those water solubilities of substances, seeing these patterns. Okay, is our job here, is what we are going to find out here. Okay, let's do it. Let's start doing that. Okay students, you would find some cations being there in substances, make them fully soluble, very soluble. What are those cations? Let's call them lucky cations. When you find these cations, these few cations within an ionic substance, it's sodium cation, potassium plus and ammonium plus. If you find these cations within a substance, then those would be water soluble for sure. Those would be water soluble. All substances having potassium, sodium and ammonium are water soluble. Then why is that? It's only sodium and potassium, not the down elements in the first group taken. Actually, those rubidium, cesium, francium, you are not going to experience much of them, means compounds of them. It is therefore, if we start talking of them as well under this category, it would start becoming not realistic much. Therefore, these are the cations that you could find mostly within substances being there, representing first group. Okay, lithium exhibits some deviations, therefore as normal, right? Therefore, we are going to take these. It's sodium, potassium, ammonium. When you have those cations within an ionic substance, those would be water soluble for sure. They do not therefore form precipitates. It's you need to see the point or the difference between water insoluble and precipitate. What's the difference of precipitate and insoluble? Students, when you add a substance inside water, if you find it's not soluble, then we call it is insoluble. But when you mix two solutions as a result of gathering or combining of those two solutions, if you get water insoluble substance being formed, let's say when you mix barium chloride with sulfuric acid, its barium sulfate is formed there. It's water insoluble. When a water insoluble substance is formed as a result of mixing two solutions or as a result of reaction having, then that substance, that water insoluble substance that formed here, appeared here newly at the moment here inside the solution, called a precipitate. Then it's not that significantly means that different, but it's actually context-wise difference. This application, that precipitate, is only when you mix things and get that substance being appeared for the very first time inside the solution. We call it a precipitate. But when it is insoluble, it's you take the solid and check it whether it's soluble or not. If you find it as insoluble, means not soluble, we call it insoluble. That's the difference between the application or context-wise, the two terms insoluble and precipitates. You need to know those technical terms. When you heat a solid, if it results something remaining, we call it a residue. Then some students I have seen that they misuse it or mispronounce it, or they apply the term precipitate here instead. No, it's you can't. It's technically wrong there. So the suitable term here is residue. Residue. Okay. So students, then it's when you find these cations being there in substances, those would be water soluble. You take any substance means having these cations, you could couple any anion. So let's say it is sodium permanganate, sodium dichromate, sodium anything, metaborate. It's having sodium, therefore it could be water soluble. See how easy? You could easily say whether it's water soluble or not. See in this sodium, it's water soluble. See in potassium, it's water soluble. So having these cations within a substance, it would become water soluble. In general, such substances having sodium, potassium, ammonium are water soluble. Then let's check for such few lucky anions. Students, it's when you have these anions within the substance. What are those? It's nitrate when you have, and nitrite, and acetate, as well as when you have bicarbonate in a substance. When you have substances having those anions, stable substances, then students, they all are water soluble. For the reason you have these anions. You take silver nitrate, you take lead acetate, you take copper nitrate, those all are water soluble. For the reason that means you could easily predict that those substances are water soluble, seeing these anions they are inside. Okay, see how easy it is the prediction of water solubility when you have these cations and anions. Okay, these are the easiest part. And when you check for some other ions, you could find some anions being there. Most of those substances having those anions would be water soluble, but only a limited number of substances could be found as water insoluble. When you talk about sulfates, it happens like that. Students, water solubility of sulfates. Most of sulfates are water soluble except the sulfates of calcium, strontium, barium. You could find them down the second group. Down the second group, sulfates water solubility decreases. So if you could find radium as well, it's radioactive, so it's not stable. You can't find normally compounds. If you have that, then that also belongs to this category. What is insoluble? Anyway, down the second group, water solubility of sulfate decreases. Then let's take some other sulfates. Lead sulfate, silver sulfate, and mercury forms Ag plus and 2 plus. When it is Ag2 plus, it is mercury. When it is Ag plus, it is mercurous. It is mercurous here you have. Students, sulfates of these are water insoluble. Only these 6 sulfates are water insoluble. All the other sulfates are water soluble. What are the water insoluble sulfates? Calcium, strontium, barium, lead, silver, mercurous. Knowing those, you know all the sulfates water solubility, isn't it? Okay. Then let's check it for the halides as well. Students, when I say halides, it's the 17 group elements are the halogens. When they form their anions, X minus, are the halides. Halogen, when they take an electron and form anions, negative anions, those are halides. It is fluorine forms fluoride, chlorine forms chlorides, bromine, bromides, iodine, iodides. Then it's out of those all the halides, I am going to talk about the chlorides and bromides and iodides only. I am dropping fluoride, the very first member in the halogen family. That anion fluoride, fluorine forms is the fluoride. Why is that? It's the experience in the periodic table for sometimes that the first member of a group, it exhibits weird properties. It happens normally, right? Normally, the first member in a family would behave quite in a weird way, would be absent, right? Okay, so I mean, when you check for the lithium in the first group, it's quite absent. Means it exhibits different properties. That's why it's not negatively. Or I'm saying it's just simply different from others. That's what I meant by absent. Okay. So when you go for the second group, beryllium is quite differently exhibit its property. It has the greatest electronegativity within the second group. So therefore, it could be seen those group wise, the first top member is quite differently behaved. So here also is the same. That's why I have not considered that. Then the pattern is disturbed. So I could prove that here, when your students check for silver's halide, Ag fluoride, Ag chloride, Ag bromide, silver iodide. Out of these silver halides, these are water insoluble. But this is water soluble. It behaves differently. Then when you take calcium, calcium fluoride, calcium chloride, calcium bromide, and calcium iodide. Normally calcium compounds are those are kind of those like water very much. Those are hygroscopic compounds. Those could attract moisture from air. Those could absorb moisture, most of them. Then these are highly water soluble. But this one, you could find in EPA, we have an apatite ore. There you have calcium phosphate and calcium fluoride in 3:1 ratio. So normally in other countries also they have some apatite ores having calcium chloride. It exhibits, those apatites exhibit some sort of water solubility there. But ours apatite, it's class 1 apatite super, right? So its water solubility is very less, it's poor. in water solubility. For the reason it's having calcium fluoride, so calcium fluoride is water insoluble. That's why insoluble. Therefore, I'm not going to talk about the fluoride's behavior hereafter. We are going to omit fluoride from these patterns. So, I'm going to show you the water solubility of chlorides, bromides and iodides only under the halides water solubility. Okay students, let's talk about the chlorides. When you check for the chlorides, most of chlorides are water soluble except 4 chlorides. If you have these 4 chlorides, what are they? It's lead chloride, silver chloride, you have Cu plus being cuprous and Cu2 plus being cuprous chloride, and you have met with this, it is mercurous chloride. When you talk about chlorides, it's lead, silver, cuprous, mercurous. Their chlorides are water insoluble, all the others chlorides are water soluble. Okay, let's talk about the bromide. For the bromide also is the same, lead, silver, cuprous and mercurous. Their bromides are water insoluble, all the others bromides are water soluble. When it's about iodide, you have the same list again, lead, silver, cuprous, mercurous, but here you have another 2 additionally, are mercury also now is there. So, and bismuth iodide. So students, only these iodides are water insoluble, all the other iodides are water soluble. So it's very easy. Seeing these patterns, you could easily view whether it's water soluble or insoluble. Any halide there. So the halides of lead, silver, cuprous, mercurous, all halides including these 3 so are water insoluble. Then for iodide, it's further mercury and bismuth are water insoluble. Then we are going to further talk about, we are going to extend this towards some other anions as well. But it won't be such simply, means it's very simple pattern you could see there, as that you found only 6 of sulfates, only 4 chlorides, 4 bromides, 6 of iodides being precipitated, all the others are water soluble. Then hereafter you will find this list getting a bit more increased. It's not that complex, it also is simple, and you could find some patterns there as well. So see those patterns and find it out how easy prediction of whether it's water soluble or water insoluble. Right? See in a substance, when you find the substance, when you are provided with the substance, when someone asks you whether it's water soluble or insoluble, not seeing that compound for real, not knowing the compound, then also you could easily say whether it's water soluble or insoluble. Actually, you could easily predict whether it's water soluble or insoluble. It's that fun, that enjoyable, this thing. Okay, let's go ahead. It's students, next what I am taking, another 2 very important anions, they are oxides and hydroxides. Oxides and hydroxides. Let's find it out, the water solubility of oxides and hydroxides. When you talk about oxide, it's O2 minus, and hydroxide, it's OH minus. Then students, regarding oxides and hydroxides, as you have already seen for these lucky ions, cations, they are oxides and hydroxide would be water soluble. Those would be water soluble. They are oxides and hydroxide. But for ammonium, you won't get any oxide. Okay, there is no such compound called ammonium oxide. Ammonium has the hydroxide only. Anyway, oxides and hydroxide of these are water soluble. Then students, it's the second group, oxides and hydroxide. Down the second group, water solubility of oxides and hydroxide increases. So the top 2 members, berylliums and magnesiums, oxides and hydroxide, are water insoluble, but calcium, strontium and barium, their oxides, hydroxides are water soluble. So when it goes to barium, it's very soluble. So down the second group, oxides, hydroxides, water solubility, it increases. When you talk about the other oxides, hydroxides, what are the other oxides, hydroxides? It's like quite whether there are any other else mango trees except this. Okay, so yes, it's those which do not belong to S group. Oxides, hydroxides of other elements. Others, oxides and hydroxides, which do not belong to the S block. Let's say, except S block, all the others, oxides and hydroxides, are water insoluble. Those are insoluble. Then it's done. Easy, right? When you talk about the oxides and hydroxides, it's sodium, potassium, ammonium. Their oxides, hydroxides are water soluble. Down the second group, water solubility of oxides and hydroxides increases. Top two members, beryllium, magnesium, their oxides, hydroxides are water insoluble. But calcium, strontium, barium, their oxides, hydroxides are water soluble. Except S block, all the others, oxides, hydroxides, are water insoluble. See how easy? Let's talk about sulfides. When you find it out, the water solubility of sulfides, what are sulfides? S2 minus ions. It's very easy. S2 minus ions, S block sulfides are water soluble. Water soluble. Then, except of S block, others, except S block, are insoluble. See how easy? The sulfides water solubility. Generally, S block sulfides, including ammonium, are water soluble. All the other metals except S block, they have sulfides which are water insoluble. S block sulfides are water soluble. Easy. So let's take a look at their water solubility of oxalates. Oxalates next. Students, when you check for the oxalates water solubility, what are oxalates? C2O4 2 minus ions are oxalates. When you take oxalates, they are oxalates of sodium, potassium and ammonium are water soluble, as they are the lucky cations. Then down the second group, water solubility decreases. Then in the second group, only top two members, beryllium and magnesium, they are oxalates only, are soluble. Then down the second group, it decreases the water solubility of oxalate. So it is calcium, strontium, barium, could name as water insoluble oxalates. Then last is the except S block. Except S block. All others, oxalates are water insoluble. Then it's easy. When you talk about oxalates, those are C2O4 2 minus and ions. So when you talk about their water solubilities of oxalates, it's you could find sodium, potassium, ammonium, their oxalates are water soluble, and in the second group it's beryllium and magnesium only are water soluble oxalates. All the other oxalates, calcium, strontium, barium, radium. Let's not take radium. So barium, their oxalates are water insoluble. It's you could say generally down the second group, oxalates water solubility, you could find that decreasing. Except S block, all the others oxalates are water insoluble. insoluble. See how easy it is. Okay, then let's find it out regarding chromates. What solubility of their chromates? When you check for chromate, students, it's Cr2 minus. Again, it will behave similarly. It is sodium, potassium, ammonium. Their chromates are water soluble for those lucky cations. Then down the second group, water solubility of chromates decreases, but for this time, it is calcium chromate also belongs to water soluble. Then its others, strontium and barium, their chromates are water insoluble now. Then except SO, all the others, chromates are water insoluble. Easy. So then let's go to the next. Students, it's finally what we are having is there are few ions, actually anions, that most of substances that they form are water insoluble. Only few they have got as water soluble. It's, you could find carbonates, sulfides, phosphate as well. When you check for carbonates, sulfides and phosphate, for them sodium, potassium, ammonium only form water soluble. Carbonates, water soluble, sulfides, water soluble, phosphates. But others are water insoluble. You take any other cation, so they are carbonate, water insoluble. All the second group carbonates are water insoluble. All the second group sulfides, phosphates are water insoluble. Any other D block metal, carbonate, sulfide, phosphate would be water insoluble. So it's very easy. It's very easy. You could then hereafter you could predict the water solubility of those substances. It's you need to know few things only. It's you need to see the patterns. Okay, let me brief those things. It's students, I would say that when you have got these cations, lucky cations, it's sodium, potassium, ammonium. When you have within a substance, those will be water soluble for sure. When you have nitrates, nitrites, acetate, bicarbonates forming stable compounds, those are water soluble. When you have sulfates, there are 6 sulfates only could call water insoluble. Those are calcium sulfate, strontium, barium sulfate, lead, silver, mercury, they are sulfate. But out of those 6 sulfates, is calcium and silvers, their sulfates would be slightly water soluble. Anyway, those calcium, strontium, barium, lead, silver, mercury, their sulfates are the insoluble sulfates. Only insoluble sulfates. All the other sulfates are water soluble. Out of those water insoluble sulfates also, its calciums and silvers sulfates you could find being slightly soluble, very slightly soluble. Okay, then when it is about halides, chlorides, bromides, iodides, they are lead, silver, cuprous, mercurous substances are water insoluble, and for iodide only it's mercuric and bismuth also you need to add. Those are the only water insoluble halides. Then when you talk about all the other halides are water soluble. Then when you talk about the oxides and hydroxide, it's sodium, potassium, ammonium form water soluble oxides, hydroxides, and down the second group oxides, hydroxides water solubility increases. Beryllium, magnesium, their oxides, hydroxides are water insoluble. Calcium, strontium, barium, their oxides, hydroxides are water soluble. Then except SO, all the others, oxides, hydroxides are water insoluble. When you talk about oxalates, it's magnesium and beryllium, top 2 in the second group, it's sodium, potassium, ammonium oxalate, water soluble. Beryllium, magnesium only soluble in the second group. Down the second group, water solubility of oxalate decreases. Calcium, strontium, barium, their oxalates are water insoluble, except SO, their oxalates too are water insoluble. When you talk about chromates, they are sodium, potassium, ammonium substances are water soluble. Down the second group, water solubility decreases. So top few, it is beryllium, magnesium, calcium. Their chromates are water soluble, and strontium, barium chromates are water insoluble, except SO, their chromates are water insoluble. Then when you talk about the sulfide, except S block, all the other sulfides are insoluble. S block sulfide and ammonium sulfide ammonium sulfide and S block sulfide are water soluble. Then students, last but not least, it's carbonates, sulfides and phosphate. When you take those substances, only sodium, potassium, ammonium are water soluble substances, soluble carbonate, soluble sulfide, soluble phosphate. All the other substances of all the other carbonates, all the other sulfides, all the other phosphates are water insoluble. Knowing this, seeing these patterns, you would easily find it out water soluble and insoluble substances. Then when you mix two substances, two solutions, and if you realize that it's this cation going to couple with this anion as to give water insoluble substance, then you start saying it's a precipitate. It's possible to form a precipitate. So hereafter, students, you could easily predict whether it's going to form a precipitate or not. If you could enjoy this part, as you could enjoy learning chemistry. Chemistry is a logic-based subject, right? So it has a logical basis, this chemistry. So you could enjoy seeing these patterns in chemistry. Okay, so it's what we have got here to offer you. So in next video, we are going to talk about another such logical theory or logical lesson. Okay students, we are going to round up here in this video. Till we meet in the next video, goodbye to you all.